All right. Hello, hello, hello. Happy Wednesday. So last time I introduced three concepts, and we talked about the 12 anatomical systems. And you had your first taste of those little quizzes. Now we're going to shift gears and we're going to get into chemistry. And anytime I say chemistry in an anatomy and physiology class, people say, why? It's because the physiology part of our course involves chemical reactions. And so in order to understand what's going on, you need to have a basic understanding of atoms and how atoms interact and why they behave the way they behave, as they say. They do have behaviors. Some of them are chill, others are highly reactive. Now, why? And it has to do, in large part, with what they are made of. So I'm going to slide out of the way here and let you see what's on the board behind me. All right, so on the board here, at the top, underscored, it says atoms are composed of 3 different types of subatomic particles. And we're going to talk about each of these. We're going to have, well, you got your protons, you got your neutrons, and you've got your electrons. Now, so you may have heard of some of these places where physicists do all this stuff of crashing atoms together, and they're trying to find little teeny other kinds of subatomic particles. These are the big ones. These are the ones that we've known about for, 100 years. I'm not a chemist, so I don't really know, but for a really long time. And I bet that every one of you, excuse me, I bet that every one of you can envision an atom, just even if it's the, nuclear program thing where you have this thing in the middle, this nucleus, and you have all these other little doohickeys flying around the outside. That's what we're going to talk about. All those other little teeny tiny things, we don't worry about them. When I first started teaching, I was in Texas, and they had a watered down chemistry class they called Cowboy Chemistry. And I always think of that Cowboy Chemistry class, the easy chemistry, but it's all of the basic stuff of chemistry. That's what we're going to talk about, but it's not hard stuff. Okay, so we're going to start out talking about those particles that are on the inside of that nucleus. We said you got the nucleus and then the things flying around outside. So on the inside, you always have protons, and you usually have neutrons. Now, I don't have a periodic table. I don't even think I have one in your PowerPoint. So I'll add one so that you have it in there, so you understand what I'm talking about. But there is a table. It's called a periodic table that contains all the different kinds of elements, of atoms, the different kinds of atoms. And to determine what an atom is, you look for these protons. Protons are big. They're found in the nucleus, and depending on how many of those you have, it determines the identity. If you have one of those, it's hydrogen. If you have 2 protons, it's helium. If you have 3 protons, it's lithium. Don't ask me to go beyond that. But okay, so the identity of the atom is determined by the number of protons. And a little later on, we will talk about something called the atomic number. And all that is a statement of how many protons are present. And it's so important because it is the identity. If you say the atomic number of 1, everyone knows you're talking about hydrogen. Now you know. Okay, so these are large. And so it has large mass, and you might wonder why I make a point of saying that. Well, it's because these particles we're going to talk about later, that are the ones that are flying around, they're tiny. And so 1/2000th the mass. So when we talk about the weight of an atom, you don't worry too much about that. That's each one of those little particles is only 1/2000th the weight of one proton or one neutron. So the one more point, the protons are positively charged. And that's going to be important when we talk about the negatively charged electrons. But we're not to there yet. So the number of protons will have an equal number of electrons. So we'll come back to this in a minute. But the other big thing that's in the nucleus are what we call neutrons. And neutrons, they have a large mass. They have no charge. They're neutral. And you have close to the same number of neutrons, the neutrons to the same number of protons. It varies, and we'll talk about what significance of that is. So we had said the atomic number is the number of protons, and then we had said we have this atomic mass or weight, and we have these two different kinds of particles. You have a number of each of these, and we said they're big. And so these are going to be the particles that are going to determine the mass or weight of the atom. Okay. So they're in the nucleus. You have these two different kinds of things. That's all you need to know about the nucleus. You see, it's easy. You need to know a little bit what I told you about the protons and a little bit what I told you about the neutrons. Now, I said flying around outside, we have these electrons. And we said they are tiny. 1/2000th the mass of these other two kinds of particles. They're negative. What about that? Positives and negatives attract. So you have an equal number in the beginning. So when, you start out with an equal number of electrons to protons. So if you had 3 protons, you would have 3 electrons. Now the funny thing about electrons is they carry energy, and they're in motion in what we call orbits, and they can have different amounts of energy. Now if you think about a little child, I always say standing up here, but I'm in front of a class, I always say standing up here in front of a class, if a mother with like a 2-year-old was to come up there and you see all those faces in front of you, the 2-year-old, they might be very intimidated by them, and so they'd have energy because they're a 2-year-old, but their mama, has a strong attraction to them, so they'd be wandering around, but they're a little leery of those people out there. Now, what if you brought in a mother and child, and the child was a little bit hyperactive, had more energy in him? He would be intimidated by those people too, but he would be more adventurous, so he would be going further away. Well, that's exactly what happens with electrons. They exist in orbits depending on how much energy they have. If you're low energy, you're close to the nucleus. If you're higher energy, you're further away. positives and negatives attract, so you never run away. You just are circling around like those children I was talking about. All right, we've gone 10 minutes. I'm going to stop right here.